Hi everyone. In this video, we are going to see the logic behind for solving the spectre problem in Codechef recent contest, that is 215. So in this problem, they are giving two arrays. One is A and another one is B, and the length of these two arrays are same. So we just need to find the intervals among these two as well. So the selecting intervals should be in such a way that the sum of the each intervals should be maximum, and as well as the intervals what are going to be selected from A and from the B should be overlaid, or I can say the indices should be, the positions should be overlapped, I can say. So let's see one thing. So for example, A is there. So these are the elements, just assume. And B is there, and in B also few elements are there. So I need to find or select an interval from A and as well as from B where the sum of these two intervals need to be maximum, and as well as these intervals should be overlaid. I mean, let's say for example, from A if I take this 1 and 2, from B I need to take this 2 and 3, or else there will be another possibility of this. So whatever the interval I selected here, the interval should be overlapped with the other selecting interval. I hope this makes sense. Okay. So now, in order to make you guys understand, I just taken that simple example, that is this is the first test case from that problem. So what I need to do here, when it comes to some of the ranges, right? That is what we are doing here. When it comes to some of ranges, uh, the simple thing or traditional approach that comes in our mind is prefixing, right? So the same thing that I'm going to apply here as well. Here a little bit twist that we have. So what I'm doing here, whatever element is there, instead of selecting the interval wherever the maximum position will come, no? So instead of searching the interval wherever we get the maximum position, what about if we select a point, the intersection point, right? It will also work, right? Kind of reverse engineering. So instead of going to selecting the interval, which is going to give a maximum I can say maximum sum, what I'm trying to do here, I'm going to find intersection point. So what I can simply do here, I will come to this array and position 0 I will point out, and at position 0 I will try to find the maximum, or I can say best sum of by including this position. What I'm doing here, simply I'm considering this as an intersection point. Okay, so 0 will be if I consider this 0 position in this array, and the intersection, that point will be considered in this as well. So for that, what I'm doing, I'm just trying to find the best sum, or I can say best interval, including this 0 from left side. Okay, so what here, it is a starting point as itself. So what I'm trying to explain here for you, I will try to take this subarray first, that is 0, comma 0. So I'm trying to take this as my intersection point, and I'm trying to find the best sum. Okay, so best sum from the starting point to this point by including the 0th position, or I can say this is my intersect point. Okay, so this is how I will try to find the best sum from left side by considering each and every index on it. So simply if you see, this is my uh, array where I can store best possible sum from left side, okay, of A. So by considering this 0 as my intersecting point, and by considering the left side, the maximum, or I can say best possible sum of the range, I can say. So that will be 10, right? And when it comes to 1, here, by including this number, whatever the selecting point is there, right? By including this number, I will get -8. So What about the previous one? So I will try to include that one as well, right? So because if I include this one, it will be one subarray for me. And as well as if I try to expand the subarray, because interval is up to my chance, or I can say my decision. So this will be my selecting point or intersecting point, and as well as I will look forward, like I will look back as well, because by including these values also, whatever the best value I got here, by including the best value here also, it will expand my span as well, right? So that's why I will again look backward and I will try to find. So here I have already -8. By including this one, I will get 2, which is a little bit, not little bit, it is more maximum with the current array, sorry, with the current element, I can say, right? So by including the first index with the previous one, I will get 2. Let's say, for example, instead of this 8, -8, if I have 100, and as well as if you have -2 here, just assume. Actually, if you select this point as an intersection point, if you try to add this previous one to this, are you going to get the maximum one? By selecting this, by taking the previous conclusion, by selecting the previous decision, I will get 98. But without considering it, I will get 100, right? Which one is better for you? This one is better, obviously, right? So what you need to do here, before considering the previous thing, just try to check. By selecting the current position only, you are going to get a, by selecting the current position only, you are going to get a maximum one, or by adding, let's say, sub prefix from left, I can say that I, or else current -1, it will give the previous value, right? So just need to consider whether this is going to give a maximum one or current itself giving the maximum one. So try to keep those things here. Okay, that's how you will get the maximum sum. And again, I will go to by considering the second as my intersection point. So it is -2, and by selecting the previous one, it is initially -2. By selecting the previous one, I will get 0, -2 and 2. So 0 is far better. So I will try to take this. And again here also, by selecting the 3 as my intersection point, I will try to take that 6 here. And from 6, by considering the 0, or else by 6 itself, both are same, so I will take 6. So this is how at each and every position, the maximum possible uh, best value I kept. Let's say, for example, in this array, you have from left side span only best value you have. What about for this 0 point? If I try to include the right values, or I can say right range also, if I increase, there is a chance for I will get maximum values here as well, right? So for that reason, what I'm doing here, whatever the thing that I have calculated from left side will be acted as a left side best value by considering each and every index point as an intersecting point. So now I'm trying to get another prefix sum, that is right. Okay. So in this, what will happen? Whatever the previous thing I have considered, I included the current one with a previous one and the maximum of the current one as well, if it is maximum, right? So in right array, what I will do, I will try to consider by right side. So at position 3, I will consider this as an intersecting point, and from right side of this, there is no element, so by default, it will be the best point for me here, right? And I will go to the second index, and second index I have -2 actually. So by considering the previous best value, I will try to get maximum value, right? When it compared with the just current value. So 6 -2 will give 4, so I updated that. And now here At position 1, value is minus 8. So value is minus 8. And if I try to add this with the previous one, I will get minus 4, which is far better than minus 8. And if by considering 0 as an intersecting point, there it is 10. And now, if I try to consider the previous one as well, I will get 6. But it is not maximum for one for me. So I will just try to exclude that. I will not going to include it as. So at zeroth condition, at the zeroth position, I can say the best value is 10, right? So whether if it might be by considering the previous value or might not be considering the previous value. So now if you see, I have left A and the right A. So don't you think that by considering these two arrays will help for me to get the maximum possible summary or a sum of summary? Yes, of course, I will get. So what I will do here by using these two arrays, I will just try to simply considering this 0 as the first point again, first intersection point. So what this left array will give? The best possible value by considering the left side, and the right array will give the best possible maximum sum by including this position from right side, right? So if I try to include these two values, here it will give the maximum or best value from left side, here it will give maximum or best right side value. So if I try to include these two, I will get the sum of maximum possible value here by including this index, right? So, but if you see this range it will take and this range it will take, but this range is overlapping again. So what I will simply do, left of a, left of A of I plus right of A plus I will give some value, but because of adding the value multiple times, here if you see, might be considered here as well and might be considered, it will be considered here. So I will try to simply exclude that value here. How I can get the value there? By taking this array. So array of I will try to remove that. So this is how I will get the value by including the ith position. Okay. And now this will be the best subarray sum I can get from left of I and left of A and right of A. Okay. So this is how I will again go for the I will be 1 and I will be 2 and I will be 3. So I will again try to update this best wherever I will get the maximum one at which position, or I can say at which I will get there, I will update this best. So that's how I will get the maximum of a maximum possible subarray of A, and as well as if I try to do the same operations on B array also, I will get the maximum again. So that is how you will get the best of A and best of B. And by adding those best of A and best of B, you will get the maximum. And there also, by default itself, these values are intersecting. Like these intervals are already intersecting and you will get the maximum value. This is how we can solve this problem.